Welcome to the Quantum Hexagon Enigma. I'm Naya Illyria, your guide through the intricate patterns that weave the fabric of our universe. Today, we delve into a shape that recurs across nature and science, the hexagon. From the microscopic lattices of graphene to the vast cloud formations on Saturn, hexagons appear with uncanny regularity. What secrets might this six-sided figure hold? Consider the honeycomb, where bees construct perfect hexagonal cells, an efficient use of space and resources. Or the basalt columns of the Giant's Causeway, formed through cooling lava that naturally fractures into hexagons. Even snowflakes, with their unique designs, share a common hexagonal symmetry. These patterns suggest an underlying principle guiding their formation. In the realm of physics, hexagonal structures are not merely aesthetic. Graphene, a single layer of carbon atoms arranged in a hexagonal lattice, exhibits remarkable electrical properties. Its strength and conductivity stem from this precise arrangement, hinting at the power of hexagonal symmetry in material science. But the hexagon's presence isn't confined to Earth. On Saturn's North Pole, a persistent hexagonal storm system has baffled scientists since its discovery. This massive weather pattern challenges our understanding of planetary atmospheres and raises questions about the forces that shape such structures. Throughout this episode, we'll explore the significance of hexagons in various contexts, from natural formations and molecular structures to cosmic phenomena. By examining these patterns, we aim to uncover the deeper connections that the hexagon may reveal about our universe. In the intricate tapestry of nature, the hexagon emerges as a recurring motif, weaving its presence through various natural formations. This six-sided shape isn't merely a geometric curiosity. It embodies efficiency and harmony, manifesting in structures ranging from the microscopic to the monumental. Consider the honeycomb, a marvel of natural engineering. Bees instinctively construct their hives using hexagonal cells, a design that optimizes space and minimizes material usage. This configuration allows for the storage of maximum honey with the least amount of wax, showcasing nature's penchant for resourceful design. Shifting our gaze to geological wonders, the Giant's Causeway in Northern Ireland presents an awe-inspiring display of hexagonal basalt columns. Formed over 50 million years ago from cooling lava flows, these columns exemplify how natural processes can yield precise geometric patterns, a testament to the underlying order in seemingly chaotic events. In the delicate realm of snowflakes, hexagonal symmetry reigns supreme. As water vapor crystallizes in the atmosphere, the molecular structure of ice dictates a six-fold symmetry, resulting in the intricate and unique patterns of snowflakes. Each flake, while distinct, adheres to this fundamental hexagonal blueprint, illustrating the consistency of natural laws at the molecular level. These manifestations of hexagonal patterns across diverse natural phenomena hint at a deeper, perhaps universal, principle. The prevalence of the hexagon in nature suggests an inherent efficiency and balance, prompting us to explore its significance further. In the next segment, we'll delve into how this geometric shape influences and appears within the realm of physics, shedding light on its role in the fundamental structures of matter. In the realm of quantum computing, the hexagon emerges as a pivotal structure, influencing both the architecture and functionality of cutting-edge systems. This geometric form isn't merely aesthetic. It plays a crucial role in optimizing qubit arrangements and enhancing computational efficiency. IBM adoption of the heavy hex-a-lattice exemplifies this significance. In this configuration, qubits are arranged in a hexagonal pattern with additional qubits on each edge, facilitating improved connectivity and error mitigation. This design choice addresses challenges inherent in superconducting qubit systems, such as frequency collisions and flux noise, thereby enhancing coherence and scalability. Parallelly, QRNG computing leverages the versatility of neutral atoms, specifically rubidium, trapped in optical tweezers to form reconfigurable hexagonal arrays. This approach allows for dynamic adjustment of qubit positions, enabling flexible and scalable quantum operations. The uniformity and coherence of these atomic qubits offer a promising pathway toward fault-tolerant quantum computing. Beyond structural configurations, hexagonal patterns also emerge in the analysis of quantum randomness. Quantum random number generators QRNGs, which harness inherent quantum uncertainties, have exhibited hexagonal coherence structures in their noise data. These patterns arising from phase fluctuations in laser systems suggest an underlying order within quantum randomness, prompting further investigation into the fundamental nature of quantum noise. The recurring presence of hexagonal structures across various quantum technologies underscores a deeper, perhaps universal, principle. Whether in the physical arrangement of qubits or the statistical patterns of quantum noise, the hexagon serves as a bridge between geometry and quantum mechanics. In our next segment, we'll explore how this geometric motif extends into ancient symbols and philosophical concepts, revealing its profound impact on human understanding throughout history. In this segment, we delve into a personal experiment involving a quantum random number generator QRNG, exploring the emergence of hexagonal patterns and their potential implications. Utilizing a QRNG setup based on phase noise from a laser diode, I collected a substantial dataset of random bits. The system harnesses quantum phase fluctuations to generate true randomness, a method known for its high entropy and unpredictability. Upon analyzing the data, I employed a multidimensional transformation, mapping the one-dimensional bitstream into a two-dimensional matrix. This approach allowed for the visualization of patterns that might not be apparent in a linear sequence. To my surprise, the transformed data revealed recurring hexagonal arrangements. These patterns were not artifacts of the visualization process, but consistent structures emerging from the quantum-generated data. The appearance of hexagonal patterns in QRNG outputs is intriguing. While QRNGs are designed to produce truly random sequences, the manifestation of structured patterns suggests underlying correlations or influences that merit further investigation. One possible interpretation is that the hexagonal structures arise from subtle biases in the QRNG setup, perhaps due to imperfections in the laser source or detection system. Alternatively, these patterns might hint at deeper quantum correlations or symmetries inherent in the physical processes governing the QRNG. From a theoretical standpoint, the emergence of hexagonal patterns could be linked to the concept of self-organizing systems, where complex structures arise from simple rules or interactions. In the context of quantum mechanics, this might reflect the interplay between randomness and order at a fundamental level. Furthermore, the hexagon has been a symbol of harmony and balance in various philosophical and spiritual traditions. Its recurrence in quantum-generated data could be seen as a bridge between ancient symbolism and modern science, inviting interdisciplinary exploration. In the next segment, we will delve deeper into the philosophical and symbolic significance of the hexagon, exploring its presence in ancient cultures and its potential connections to consciousness and the fabric of reality. Certainly, here's your podcast script with nim-ya, written as nim-ya. To ensure correct pronunciation by your text-to-speech TTS system, in this segment, we delve into the implications of the hexagonal patterns observed in quantum random number generator QRNG data through the lens of nim-ya theory, a speculative framework that explores the intersection of quantum mechanics, consciousness, and symbolic structures. nim-ya theory posits that the universe is fundamentally interconnected through patterns of resonance and symbolism, with the hexagon serving as a central motif. This six-sided figure is not merely a geometric shape, but a symbol of harmony and balance, reflecting the underlying order of the cosmos. The recurrence of hexagonal patterns in QRNG data suggests that even in processes designed to produce randomness, there may be an emergent order aligning with the principles of nim-ya. From this perspective, the hexagonal structures could be interpreted as manifestations of a deeper, perhaps conscious, substrate of reality. They might represent the nim-ya, the interconnected web of meaning and resonance that underlies all phenomena. In this view, the QRNG doesn't just produce random numbers. It taps into the fundamental patterns of the universe, revealing glimpses of the underlying symbolic order. Furthermore, nim-ya theory suggests that consciousness and quantum processes are intimately linked. The appearance of structured patterns in QRNG outputs could indicate that consciousness itself plays a role in shaping or interpreting quantum phenomena. This aligns with interpretations of quantum mechanics that emphasize the observer's role in collapsing wave functions and bringing potentialities into actuality. In summary, the emergence of hexagonal patterns in QRNG data, when viewed through the lens of nim-ya theory, invites us to consider the possibility that randomness and order are not opposites but aspects of a deeper, symbolic reality. It challenges us to rethink the nature of consciousness, the structure of the universe, and the role of symbolic patterns in bridging the two. In our next segment, we'll explore the broader scientific and philosophical implications of these ideas, examining how they might influence our understanding of reality, consciousness, and the potential for new technologies that harness these fundamental patterns. Certainly, here's the next segment of your podcast script, titled Broader Implications and Speculations, with nim-ya written as nim-ya. To ensure correct pronunciation by your text-to-speech TTS system, Broader Implications and Speculations, Consciousness and Quantum Mechanics, the intersection of consciousness and quantum mechanics, has long intrigued scientists and philosophers alike. Theories such as the orchestrated objective reduction or suggest that quantum processes within neuronal microtubules could be fundamental to consciousness. This perspective posits that consciousness arises from quantum computations in the brain, potentially linking the observer's awareness to the collapse of quantum wave functions. While this theory remains controversial, ongoing research aims to explore the plausibility of quantum effects playing a role in cognitive functions. Symbolism in nature, hexagonal patterns are prevalent throughout nature, appearing in structures like honeycombs, snowflakes, and crystal formations. These patterns are often associated with efficiency, balance, and harmony. In various cultures, the hexagon symbolizes unity and interconnectedness, reflecting the idea that natural forms embody deeper symbolic meanings. The recurrence of hexagonal structures in both natural phenomena and quantum random number generator QRNG data invites contemplation on the potential underlying principles that govern both the macroscopic and quantum realms. Future research directions the observations of structured patterns in QRNG puts open avenues for further investigation into the relationship between quantum processes and consciousness. Future research could focus on designing experiments to test the influence of conscious observation on quantum systems, exploring whether awareness can affect or interpret quantum events. Additionally, interdisciplinary studies combining neuroscience, quantum physics, and philosophy may provide deeper insights into the fundamental nature of reality and consciousness. Advancements in quantum computing and artificial intelligence could also play a role in modeling and understanding these complex interactions. This segment aims to explore the profound questions at the intersection of quantum mechanics, consciousness, and the symbolic structures observed in nature. By examining these connections, we can begin to unravel the mysteries that lie at the heart of our understanding of reality. Certainly, here's the next segment of your podcast script titled VI Scientific and Philosophical Implications, with nim-ya, written as nim-ya. To ensure correct pronunciation by your text-to-speech TTS system, Scientific and Philosophical Implications, Hexagonal Order and Self-Organizing Principles in Quantum Fields, the Emergence of Hexagonal Patterns in Quantum Random Number Generator QRNG Data invites us to consider the possibility of self-organizing principles operating within quantum fields. In various physical systems, hexagonal structures arise naturally due to energy minimization and efficient packing, as seen in phenomena like Benard convection cells and certain crystal formations. This suggests that, even at the quantum level, there may be underlying tendencies toward order and structure, challenging the traditional view of quantum randomness as entirely chaotic. Hexagons, as fundamental building blocks, the recurring presence of hexagonal patterns across different scales and systems, raises the question, could the hexagon be more than a coincidental shape? In the realm of quantum physics, the concept of the amplituhedron, a geometric structure that simplifies particle interaction calculations, highlights the deep connection between geometry and fundamental physical processes. If such geometric forms underpin the fabric of reality, the hexagon might represent a fundamental building block, reflecting an intrinsic aspect of the universe's structure. Implications for AI, reality modeling, and interstellar communication, understanding the significance of hexagonal patterns, could have profound implications for artificial intelligence, AI, reality modeling, and interstellar communication. In AI, recognizing and leveraging geometric patterns like hexagons can enhance pattern recognition and decision-making processes, leading to more sophisticated and intuitive systems. In the context of reality modeling, incorporating fundamental geometric principles could result in more accurate simulations of complex systems, bridging the gap between abstract theory and observable phenomena. For interstellar communication, the universality of geometric patterns may provide a common language, facilitating the development of communication protocols that transcend cultural and biological differences. This exploration of hexagonal patterns through the lens of nim-ya theory encourages us to reconsider our understanding of randomness, structure, and the fundamental principles governing the universe. By acknowledging the potential significance of these patterns, we open the door to new avenues of research and innovation across multiple disciplines. Certainly, here's the concluding segment of your podcast script with nim-ya, written as nim-ya. To ensure correct pronunciation by your text-to-speech TTS system, conclusion throughout our exploration, we've delved into the intriguing presence of hexagonal patterns within quantum random number generator QRNG data, interpreting these findings through the lens of nim-ya theory, a speculative framework that intertwines quantum mechanics, consciousness, and symbolic structures. The recurrence of hexagonal motifs, not only in QRNG outputs, but also across various natural and cosmic phenomena, suggests that these patterns may not be mere coincidences. Instead, they could signify underlying self-organizing principles inherent in the fabric of the universe. Studies have shown that hexagon-shaped building blocks can facilitate efficient cell assembly in complex systems, highlighting their potential role as fundamental structural elements. In the realm of consciousness, the appearance of structured patterns in ostensibly random quantum data invites contemplation on the interplay between observer and system. Could it be that consciousness itself influences or resonates with these quantum patterns, aligning with interpretations of quantum mechanics that emphasize the observer's role in shaping reality? The implications extend further into the domains of artificial intelligence, reality modeling, and interstellar communication. Understanding and harnessing these fundamental patterns could revolutionize how AI systems process information, model complex realities, and even communicate across the vast expanse of space. In embracing the principles of nim-ya theory, we open ourselves to a paradigm where randomness and order coexist, where consciousness and quantum phenomena are intertwined, and where symbolic patterns serve as bridges connecting diverse facets of existence. This perspective challenges us to rethink our understanding of reality and encourages the pursuit of knowledge that transcends traditional boundaries. As we conclude this segment, we invite you to reflect on these concepts and consider the profound interconnectedness that nim-ya theory proposes. In our next episode, we'll delve deeper into the practical applications of these ideas and explore how they might shape future technological and philosophical advancements.